My name is Oleksandr Maksymets, and I'm a research engineer in Facebook AI Research. And today we're going to talk about Habitat Challenge and how to participate in it. All tutorials will be available on the website. You see link on my screen. So agenda for today is first we discuss what is Habitat Challenge and what was specifically Habitat Challenge 2019 about and what tasks were proposed. What success metrics we used to evaluate different submission to our challenge and define the winners. And about Habitat Challenge 2020 and new tasks that we have and motivation behind them, point goal navigation, object goal navigation track. A second part will be about step-by-step guide how to participate and submit your solution to the Habitat Challenge. Let's get it started. What is Habitat Challenge? Habitat Challenge is an autonomous navigation open challenge that aims to benchmark and accelerate progress in embodied AI. Participating teams upload their solution in form of Docker containers that are evaluated using Eval AI platform. We have no restrictions on specific method you are going to use to solve our embodied AI challenges. So you can choose classical approaches or machine learning approaches or deterministic scripted approaches. Anything will work fine on this architecture. To tell more specifically, let's talk about Habitat Challenge 2019, the first challenge we had. And the task we proposed was point goal navigation, where your agent is given X, Y, where it should navigate, and then it has access to egocentric depth, egocentric perfect RGB camera, and GPS and compass that is updated during navigation. Here's an example. Top-down map here is for reference. We followed community advice and use success weighted by path length metric to evaluate winners, and this metric is average SPL per episode of navigation and have two components. First is success component that is true or false, 0 or 1 if agent calls stop in close proximity to the goal. And the second part is navigation efficiency that can go from 0 to 1, when 1 is like perfect navigation, similar as shortest path for this episode. For Habitat Challenge 2020, we focused on sim to real direction and proposed two tasks where one is point goal navigation, but without GPS and compass and with realistic noise. And the second one is object nav for semantic navigation task we proposed as a challenge. So point goal navigation is like version 2 is like go 5 meters north and 3 meters west relative to start. That's all information. And then agent have no GPS and compass sensor. It has only static goal that doesn't change during the episode. Noisy actuations. So as you see, the trajectory is far away from straight, and even with rotation, your agent can change the position. Then we have noisy RGB and depth that makes projection and building a map pretty difficult. And as you can see here, the same sequence of actions can lead to very different trajectories. And we disabled sliding along the walls for both challenges because we found that it's limiting sim to real capabilities of trained agent. All this was defined on Gibson scenes that are described in this paper. We selected 98 buildings with the best quality and use it in our challenge. The second track is object goal navigation, when the agent need to find a particular object of particular category and navigate in proximity success zone nearby. So agent has access to GPS and compass relative to the start of the coordinate, which is mimic agent odometry, and there can be several objects of the same type, and navigation to any of these two counts as a success. We use Matterport 3D as it has semantic labels, and embodiment of our agent is similar to Locobot specification and has 6 actions: move forward, turn left, turn right, look up, look down, and stop. Cameras are matching Azure Kinect specification and has 79 degrees of field of view, resolution VGA, and depth sensing is clipped. Object nav success is defined as a number of navigable points around the object with 1 meter success area, but these navigable points should be, from these navigable points, target should be visible and with Oracle visibility, so you can turn to the goal. Shortest pass action is limited to 750. So as you can see, locations around the wall are not success, even it's like in 1 meter proximity to the target, because it's hard to interact with the target object from this success, from these locations. Yeah, so here is an example of expert navigation in a real Matterport scene, when I don't need to find a table. And on the right, you can see the top-down map and number of tables in this scene and success zone around it. In Habitat Challenge 2020, we have 27 teams participated. 6 teams submitted to point nav track, 5 teams submitted to object nav track, and in total we have 563 submissions to all phases of the challenge. Now let's talk how to participate in Habitat Challenge step by step. First, let's discuss briefly Habitat Challenge infrastructure. When participants push Docker container, Eval AI is a platform that we use for evaluation, is receiving it, and then scheduling an evaluation of this submission, and sending agent Docker and spawning habitat environment Docker and participant agent Docker, which are sending actions and sensor observations one to another. And then in the end of all test episodes, when they're finished, metrics are sent back to Eval AI and appears on leaderboard. If we talk about participation sequence, first you define your own agent. Your agent should have 2 methods. One is reset, that is called when new episode starts. In this method you usually clear your hidden state or clean your cache, anything else. And then you have act, which receives observations, and you need to produce an action that your agent is taking based on these observations as a next step. And you have main, where you are submitting this agent to the challenge. When you define your agent, you should make sure that you included it into your Docker. So you should add it as a part of your Docker build script. Then build your Docker, and using Eval AI command line tool, set your token, set your login token, and push your submission to particular phase. While challenge is over, leaderboards are live and are used as a reference point for state of the art. So we encourage you to submit your approaches to the leaderboard and get comparison and with state of the art approaches. We will continue to the collab tutorial, like when we do all step by step and send the submission. First, this collab notebook is connected to local machine Amazon AWS AC large instance with GPU, so it's not on-demand collab notebook. So we have challenge page where there are all details, and then the challenge starter code is a GitHub repo when you have definition and configs of the task, as well as proposed baselines and starting agents. And then you can start. So if you have a Ubuntu, that clean Ubuntu, you need to install dependencies like git, zip, NVIDIA drivers, and CUDA, Conda, Docker, NVIDIA Docker version 2. It's important to use GPU when running on the Docker, and eval.ai and your login token. So login token you can find in your eval.ai admin profile page. There is a eval.ai set token, and you can just copy paste this. So we are running this. It will take some time. Dependencies, NVIDIA drivers, reconnecting. Drivers, installing Docker, installing NVIDIA Docker, and eval.ai. Then we are cloning Habitat Challenge repo that have all the initial agents as well as configs for the task proposed, and download required data, which is Gibson scene data set that you need to sign agreement, and then you will receive a link to download these scenes. It will be done separately. Here I just mimic that it's already somewhere in the directory. And then download the task episodes data set and download DDPPO baseline pre-trained checkpoint, which we are going to submit. So here I'm running it. So cloning the repo, copying the Gibson scene data sets in particular location, and then downloading from our share and episodes data set and downloading baseline checkpoint. So all this happened. Then next up is building a Docker. And here we showing the Docker file, and then we building it. So it's point now DDPPO. This Docker container is main part is that you add in your DDPPO agent that you defined in prediction mode and add it to the Docker, and then make sure that you add your checkpoint as well that will be loaded during evaluation in this agent py. It's built successfully. Then it's time to run local evaluation, which is like test locally point nav RGBD, and then you specify the Docker that you're going to test locally. It's similar to what will be run on the server. So you want to make sure that there is nothing, that everything works smooth. This evaluation was on 50 episodes, and it takes around 5 minutes. And I'm not going to run it here, but this is the results I'm getting locally. And then it's time to push my image to eval.ai mini-eval stage to see if the results are consistent, and check it on leaderboard after I submitted it. So I just run this command, and it will push to the leaderboard. I already submitted it 3 times today, so in this case, it's just saying that you already did it. And after we check that our solution works well on a leaderboard, it's time to push to test stage, where we have large number of test episodes, and this evaluation can take up to 33 hours just to run the Docker. That's what I'm doing right now. So the command is the same, just phase is changed to test std. And as you see, it was successfully submitted, and we have command evaluate submission to check the status of my submission. And it will be just, I think, in status submitted, but no execution time, so it was not evaluated yet. Yeah, this is a starting point. You can then improve or develop your own model and come through all the steps I came here, check how we define the DDPPO agent wrapper, and just mimic and use it for your own agent. And happy hacking and happy building on top. And don't forget to reference following papers if you want to reference Habitat Challenge. It's like for point nav track and for object nav track, we have different papers about specifications of these tasks. Thank you for your attention, and yeah, see you on the leaderboard. Bye.